uh, the students were discussing about chirality and optical activity. So far we have not discussed anything about optical activity. We are still discussing about chirality. So I will take up molecules which have one asymmetric center. So first we'll deal with molecules with one asymmetric center. Asymmetric center or asymmetric carbon. We'll deal first with them. Molecules with one asymmetric center. And say that a molecule with one asymmetric carbon, such as 2 bromo butane, can exist as two different stereoisomers. Can exist as two different stereoisomers. For example, we'll take the example of this 2 bromo butane. This is the structure of 2 bromo butane. We have carbon here, bromine here, CH2, CH3, this is 2 bromo butane. We have shown this three-dimensional arrangement of groups. So if we put a mirror here, its mirror image will be like this. It's very easy to draw its mirror image. It will be its mirror image. Means this molecule in the mirror will look like this. Bromine here. You have a CH3 here. And you have here CH2, CH3. You can see these two isomers here. These two isomers here, they are mirror images of each other. But what kind of mirror images are they? They are non-superimposable mirror images. They are non-superimposable mirror images. Means you cannot superimpose them on each other. Such non-superimposable mirror images, they are known as chiral molecules, or asymmetric carbons they are called. They are known as chiral molecules, or they are also called as asymmetric centers or asymmetric molecules. They are also called as asymmetric molecules. If you see, if you check these two molecules closely, you will see that 2-bromobutane, which has this formula CH3 CHBr CH2 and CH3. This is 2-bromobutane. This 2-bromobutane can exist in two forms. It can exist in two forms because there can be two possible arrangements of atoms or groups attached to this carbon. This is the central carbon. This is the same carbon that we are discussing here. It's the same carbon. So these four groups, this is 1, 2, 3 and 4. These four groups have two kinds of arrangements around this central carbon. One kind of arrangement is shown here and another kind of arrangement is shown here. If we look at these two molecules superficially, they look to be same, but they are not same. You see here with this bromine, you see with this carbon, this bromine is attached here, this bromine is attached here in this isomer. I will write like this. Here you have hydrogen on the right side, but here you have hydrogen on the left side. Here you have this ethyl group on the left side, here you have this ethyl group on the right side. Methyl, there is no difference at all. So you see there is a different arrangement of atoms or groups around this central carbon. So this is a general example of a general example of stereoisomerism, but we call them configurational isomers here. They are known as configurational isomers. In order to convert one isomer into another, we have to break these bonds. These bonds we have to break. We have to break this bond and this bond in order to interchange, in order to exchange their positions. So such molecules are known as chiral molecules. Chiral molecules. I will give you a 3D representation of this in another slide. Here is the perfect example where you can understand this. Here you have an example. This is a chiral molecule, right? Because this central carbon, it is attached to four different groups: 1, 2, 3, 4, right? And this molecule here, this one is the mirror image of this one. They are mirror images. But what kind of mirror images are they? Why they are mirror image? This is a mirror here. It's a mirror here. Okay. So they are mirror images of each other. They are they superimposable or non-superimposable? They are non-superimposable. They are non-superimposable mirror images. They are non-superimposable mirror images of each other. this concept of non-superimposability will be clear here. You see, here these molecules are a little bit farther from each other. Here in this image we have tried to superimpose them, but will not superimpose them. Why? Because this carbon here, it will superimpose with this carbon. This hydrogen here, it will superimpose with this hydrogen here. This group here, it will superimpose with this green group. So carbon can be superimposed, hydrogen can be superimposed, this green group can be superimposed. But there is a problem. If we try to superimpose this, it has to be superimposed with this one, right? But they are different groups, we can't superimpose them. Here, if we superimpose this with this, but they are not same groups, they will not be superimposed. So you see, if a central carbon is attached to 4 different groups, you will never be able to superimpose their mirror image. You will never be able to superimpose their mirror image. So such mirror images are known as non-superimposable. They are known as non-superimposable mirror images. It means that these two molecules, this molecule and this molecule, they are different molecules. They are different stereoisomers. Means this has one arrangement and this has another kind of arrangement. So such stereoisomers are known as, we call them as enantiomers. They are known as enantiomers. What are enantiomers? Enantio comes from the Greek word. Greek word is enantion. It is enantion. Enantion means opposite. They are opposite to each other. Their stereochemistry is opposite to one another. So a chiral molecule can have with one chiral center, with one chiral or asymmetric carbon, can exist as two enantiomers. So these enantiomers, they are different molecules. They are not same molecules. They look to be same, but they are not same molecules. Although their physical and chemical properties are to a lot of extent they are same, but they are not 100% same. They have a difference in various aspects, and those aspects we will study later on. So they are known as enantiomers.